Good day, students. We will discuss this in this video lecture the topics for the module 1 in computational science CS elective 2. So this is just an overview of computational science, and this video lecture will just be on uh, the topics for the module 1. All right, so let's start. Okay, so according to Thomas Kuhn, he is he's the author of the structure of scientific revolution. And he said that the scientific revolutions are those non-cumulative development episodes in which in an older paradigm is replaced in whole or in part by an incompatible new one. So normally specified here that the revolution or the scientific revolution, okay, mentioned here is that this refers to the discoveries of the 16th and the 17th centuries in Europe, and which actually changed also the Western view of the natural world. And this began in uh, this began with the sun, no, being the center of the universe, which was the author or authored by Copernicus and continued by Newton, no, who proposed the gravitation and laws of motion. No, so sila ang nagsugod. And during the 20th century, no, according to the physicist, no, according to this physicist, si Kaku, no, there were actually three scientific revolutions. The the quantum revolution, which is biomole the the also the biomolecular revolution and the computer revolution. So at this uh, moment kani si quantum actually sa karon wala pa kay ni siya, although na uh, experiment pa ang nahitabo, but we can actually observe, no, that the rapidity with which the recent scientific advances uh, have been made, no, with each discovery sa sa atoang the way we live, and uh, in our habitats atong gipuy-an, and often sa universe. So mo nay murag impact, no, sa ani nga mga revolution. So kani sa quantum revolution, this is actually the study of the quantum, no, or the quantum physics, and which is kuan pod murag parallel siya sa study sa computer, no, the evolution, but on different level. And uh, we can actually observe, no, which of these three ang ang mas ni boom jud, or mas nag nag uh, ni nakita jud nato karon, no. So early in 21st century, uh, the Microsoft research, they convened, no, a workshop of international authorities, and they devised a vision roadmap of the evolution and challenges potential of computer science and computing in scientific research during the next 15 years. So imagine this was actually uh, predicted, no, that the outcome will be on 2020. Okay, so this research was in 2006, and they have this vision roadmap, no, the roadmap that challenges the potential of computer science and computing. So what they predicted, it actually marks the beginnings of a new scientific revolution where see computation or see computational science will become uh, uh, more an adjunct, no, support of most of the scientific research, especially karon. Okay, and computational principles and tools will become integrated into science, no, where uh, ang science o ang computer is now being or the computer or the principles in computing is gi-integrate siya, no, sa science or sa mga researches. And computational science in both theoretical, experimental, and experimental sciences will actually greatly augment the rates of scientific advances that will benefit the planet and our species. Okay, so for example, uh, the this one, the result of the Human Genome Project, no, which depended upon large-scale computational science and have encouraged uh, um, thousands or many new research and developments, government and universities and mga commercial laboratories. And one significant nga outcome from these projects will be far better understanding of molecular mechanisms sa or that underlie human disease and ang effectivity sa treatment, no, kanang mga sakit karon like AIDS nga wala pay tambal, alright, ang mga cancers nga wala pay tambal. And this is actually a project, and with the help of computational science, no, ma ma-analyze nila ang data, and that will help them uh, decode or discover more effective treatments in treating this uh, diseases nga wala pa siya tambal. And also the second one, in 2005, the president's IT advisory committee, no, he released a report entitled Computational Science is Ensuring America's Competitiveness. And they concluded that computational science and high performance computing could be integral to innovations in all of the sciences, no, sa biology, sa biomedical, physical and social, also in engineering, in industry and in defense. So ma-apply ani nga mga fields, no, ang kaning computational science. Okay, so uh, kani si katong gisgutan nato ganiya is that it falls under the biological and biomedical, no, sa mga medicines, and sa engineering, sa industry and also sa defense. And advances in computation that allows us to acquire and analyze streams of data, and that made it possible to solve problems, no, katong mga data nga nagather that will actually uh, helps, no, those enormous streams of data helps, no, helps to consider and solve problems. Computational science also allows us to build models, no, and visualize phenomena and conduct experiments difficult or impossible in the laboratory. So kaning mga model, no, nani mga mga graphs nga makita where we can see the or where we can analyze the extracted data. Also, we can visualize, no, phenomenon like mga storms. We can actually predict, no, unsay behavior sa mga typhoon, no, and that is actually very helpful. And kanang sa mga linog, no, ma-predict na, and uh, other experiments difficult or impossible sa laboratory. And we can now examine interactions in systems that involve more than one discipline, no, dili lang isa ka isa ka field, no, encouraging us to collaborate with specialists in other fields as well. Okay. uh, Computational science, the this fast growing interdisciplinary field, no, we say it is interdisciplinary because we just this is just this doesn't just apply to computing or in sciences, but also in other fields as well, no, in mathematics, in other sciences that will require and this actually require scientists who are appropriately trained, no. So the experts katong nag-produce sa katong towards 2020 nga science nga project, they predicted that future scientists who are not computationally and mathematically literate will be unable to do science. So gipredict niya nga og wala kay background ani nga mga subjects, it will be difficult, no, to do, or you'll be unable to do science. And si Robert Harrison, the director of the Joint Institute of Computational Science sa University sa Tennessee, na siya he states that in the GICS mission webpage, to translate even the most elementary theories into useful tools for physical chemistry discovery, you have to do large scale computation, no, ni ana siya. Then he added, if you look at students coming into graduate program and from the undergraduate world, no, when we say graduate program katong mokuha og mga masters, and kaning undergraduate world gikan sa undergraduate world katong mga degree courses, those that haven't already had some exposure to computation such as thinking algorithmically, solving problems on the computer, and the little bits of applied math that you need to understand all of that, have lost a year or two of productivity to the graduate level. So, katul ko nung yan na siya nga. Kung lantaon ko na nimo tong mga estudyante nga uh, gikan sa kuan degree, then nikuha og masters, those also nga uh, wala jud na expose to this type of subject and computation, such as thinking algorithmically, no, or solving problems on the computer, they actually have lost a year or two of productivity. Mas biya sila, but it's not only the undergraduate, no, coming into graduate school that have this issue. It's also our undergrads, no, going off into the larger world, no, katukunong ng graduate o inaani nga course, no, or some other courses na they are aiming for scientific research or uh, projects that involve computational science, no, they will actually face, no, this kind of issue. Uh, so industry and many other aspects of the commercial world use simulation and computation in diverse ways. Okay, so si computational science, which uh, na siya combination ni computer simulation, scientific visualization, mathematical modeling, computer programming, data structures, networking, database designs. They can transform, no, practices in a diverse range of disciplines. Its computer models and simulations offer valuable approaches to problems in many areas. So, for example, okay, so we have here our first example is a mathematical modeling has impacted our understanding of HIV pathogenesis. So, scientists, no, uh, from University of Minnesota, they wrote mathematical modeling has impacted, no, kanisha. Now, before modeling was brought to bear in a serious manner, uh, si AIDS kuno was thought, no, to be a slow disease in which treatment could be delayed until symptoms appeared, and patients were not monitored very aggressively. Okay, and uh, in the large multi-center AIDS cohort studies aimed at monitoring the natural history of the disease, blood typically was drawn every 6 months. So, mo na mahitabo na if a person is if having or kanang naka contract ani nga sakit, no, na ay sakit na ay AIDS, no, ginakuha na sila dugo every 6 months, and their blood uh, is being observed, and that happens, no, way beyond, no, or before pa jud paggawas ani nga sakit. And there was a poor, no, before there was a poor understanding of the biological process that were responsible for the observed levels of virus in the blood and the rapidity at which the virus became drug resistant. So naadyo ni siya level nga, and it was observed for uh some levels that this virus, no, became resistant, no, sa tambal. And modeling coupled with advances in technology has changed all of this, no, using modeling and technologies. This was actually changed, and dynamic modeling has not only revealed uh, important features sa HIV pathogenesis, but has advanced the drug treatment. Okay, so mas mas na improve, no, ang pag-treat sa mga na-HIV. So since then, si Perelson and other researchers, they applied, no, modeling to enhance our understanding not just sa HIV AIDS but also some other nga mga sakit like hepatitis C virus, which causes widespread infections and is the primary cause of liver cancer sa US. So, ito jud ni actually mas daghan ni didto kaning hepa. And uh, si Perelson and other researchers, they use the applied modeling para mas masabtan pa nila ang kaning si hepa C. And such models have already revealed much about the pathogenesis of the virus. no, mas nakita nila, mas gi-reveal dito sa model, uh, unsa pa joy kaya buhatan sa virus and ang effectiveness sa pag-ayo ani. Okay? And the influence also of genetic variants in the kinetics of the virus. Okay, so second, from 1960s, numerical weather prediction has revolutionized forecasting. So dugay na gid since 1960s. They have uh there are many weather prediction na nga gibuhat or gidesign. Since then, forecasting, no, when like sa mga balita makita nato nga magbalita na gani about sa mga storms na naa sila'y kinatawag nga visualization na makita nato nga asa padulong ang storm unsa ka kusga ana. And uh advances in computing continue to drive better forecasting as weather researchers develop improved numerical models. The kaning WRF, or what we call as the weather research forecasting, this was actually a kuan po niya siya kanang this is for weather prediction, no, and was released in 2000. So the latest version of this model utilizes multiple dynamical cores and allow for sa tawag ani mas dali siya makadetect, no, mas dali siya na siya three-dimensional variational data assimilation system nga mas maka-analyze siya volume of data. So this sophisticated mesoscale horizontal scale of 2 to 2000 kilometers numerical weather prediction is useful for forecasting and research. So dako yang range nga kaya basaon. Okay, so ikatulo, multidisciplinary team sa University gyapon sa Tennessee is using computational ecology to study complex options for ecological management of the Everglades. Okay, so sa kuan ni siya sa environment or sa ecology, and sa surroundings, no, they were actually studying, no, or using surroundings as data input. Okay, so sa South Florida, they have a well-known history of disruptions to normal water flow sa suba sa mga streams nila. And the University in Tennessee group, they develop a parallelized landscape population model, or ALFISH, to integrate with other models in multi-scale ecological multi-model. Okay, so ALFISH, this project is used, no, to model the effects on freshwater fish, no, makita nila unsay behavior sa in the model that they have created, makita nila ang or ma-observe nila ang behavior sa freshwater fish like planktivorous and piscivorous of different water management plants. And these fish populations, it represent the food resources for birds, and they can actually link, no, the fish model with wading bird models to help sustain the higher level multi model. Okay, so that is for computational ecology, no, or computational science used or applied in ecology. Okay, number 4, the application of computer modeling is applied in the area called linguistics. So, uh, just a little bit of background. The origin of Indo-European family of language is rather hotly debated, no, between proponents of two hypotheses. Kanisi Eurasian steppes, no, which is 66,000 years ago, no, versus Anatolia, mostly in present-day Turkey, and 8,000 to 9,500 year ago, kanisi Anatolia. So this family of languages, no, mo ni murag gigikanan, no, or the origin of the languages that we have nowadays. So this family of languages has given rise to 400 modern languages. So imagine ina nakadaghan ang nahimong uh, result, no, spoken by about 3 billion people. And recently, uh, in si Quentin Atkinson and his colleagues utilized evolutionary models for the language, no, often employed to ascertain the origin of uh, also for the viruses, no, that utilize or viruses that lead to epidemics to analyze this problem. No? Aside sa language, no, there are others also who utilized evolutionary models to to see or to know kung unsa origin sa viruses nga nanggawas, for example kanang mga uh, katong flu sa una, no, mga inana nga mga virus. And based on common vocabulary words from various languages in the family, the model supports Anatolian origin as a agricultural techniques were broadcast. Okay, so the result, ani, the experts actually uh, have a something to consider, no, in as a result after sa ani nga mga uh, studies. All right, so those are the examples. And computational science, also known as scientific computing, no, or scientific computation, is a rapidly growing field that uses advanced computing capabilities to understand and solve complex problems. All right. Okay, so uh, other fields, no, nga nahimong uh, part, no. This is actually interdisciplinary field, no. Other fields that incorporate and integrates the integrated in computational science, no. So these are the applied discipline, the computer science and mathematics. Kining uh, mathematics more on computation and uh, theories and equations, and computer science in the field of programming and or applied computer and some other applied disciplines or some other disciplines, no, like in sciences. Okay, so see, computational science is in between of these three disciplines, so naa siya aning uh, tulo. All right, so here is uh, an exercise, no, for you to answer. Now this uh, activity is also posted in the Quipper, so just check the posted quiz there and submit it on time. So I think this is all for this topic, and thank you.